falls and most people on Earth are asleep, another world awakens in solitude and mystery. That is Pluto, a distant world located at the edge of the solar system, where its surface temperatures create harsh environments unimaginable to humans. Pluto's extremely cold environment is so terrifying that even the most resilient organisms on Earth could not survive here. So imagine, if we had to face the harsh environment on Pluto, what would happen? Pluto, a remote and mysterious dwarf planet located at the edge of the solar system, averages 6 billion kilometers from the Sun. In fact, Pluto's orbit is highly elliptical, so this small world can be anywhere from 4.4 to over 7.3 billion kilometers away, depending on its position in the orbit. It is considered one of the coldest objects in the solar system, with surface temperatures maintained around -230°C year-round. Compared to the warm and pleasant climate on Earth, Pluto's extremely low temperatures create a unique and harsh environment for this dwarf planet. It would be difficult for any living organism to survive under such conditions, and even water cannot exist on Pluto's surface. Its atmosphere is very thin, mainly composed of nitrogen, methane, and some other gases, and there is almost no suitable environment for life. On this frigid celestial body, everything appears cold and desolate. Pluto's surface is made out of frozen nitrogen and methane ice, forming long ice floes stretching for miles. These massive ice blocks traverse the planet's surface terrain, creating various shapes. Some resembling steep canyons, others like oddly-shaped hills, condensing all traces of the planet. What is frightening about Pluto is not only the cold, but also its perpetual darkness. Due to Pluto's distance from the Sun and the eccentricity of its orbit, the planet's night can last for decades on Earth, while daytime lasts only a few short hours. Pluto is a completely dark world at night, with no stars, no moon, and no light sources for humans to illuminate. Except for the weak daylight during the day, almost no other light can penetrate the thick ice layer. Scientists are striving to reveal the true face of this mysterious planet through research using telescopes and satellites. Scientists hope that through these efforts, they can uncover the secrets hidden behind Pluto and provide more insights for future space exploration. Besides the cold and darkness, Pluto's strong winds are also part of this frightening world. Although Pluto's atmosphere is relatively thin, it still produces strong winds. Its surface terrain is almost entirely unprotected, with no mountains or atmospheric shields to weaken the wind. In this environment, any wind moving across Pluto's surface can easily blow everything away. If compared to other planets, it can be said that Pluto is unusually cold. As we know, Pluto's surface temperature is around -230°C, a number almost unimaginable. For comparison, the average temperature on Earth's surface is about 15°C, meaning Pluto is 25 times colder than Earth. This extremely low temperature makes Pluto one of the coldest planets in our solar system. There are two main reasons why Pluto has such an unusually cold temperature. First, Pluto is very far from the Sun, causing solar radiation energy to be only about 1/10,000th of what Earth receives. This means Pluto's surface has almost no energy supply to maintain warmth. Second, Pluto's atmosphere is very thin. This is completely opposite to Earth, where the atmosphere can retain heat to some extent. Pluto's atmosphere cannot effectively absorb and store heat, causing its temperature to continue to drop. Additionally, Pluto's extremely low surface temperature also comes from its material composition. Pluto's surface mainly consists of ice rock, and these ice rocks become extremely hard at very low temperatures, unable to absorb and store heat effectively. This poses a great challenge to the existence of life. Such harsh conditions make life on the edge nearly impossible on Pluto. However, scientists continue to conduct in-depth research on Pluto, trying to find possible microorganisms or other life forms we do not yet know. More specifically, this severely affects the physical and chemical processes on this dwarf planet. Pluto's low-temperature environment has a significant impact on the state, movement, and phase transition processes of matter. Matter in low-temperature environments moves relatively slowly because low temperatures reduce the average kinetic energy of atoms and molecules. This makes convective gas activity almost non-existent on Pluto, while climate and winds are mainly influenced by thermal radiation and weaker Aeolian dynamics. First, the low temperature turns most matter into ice forms, including various types of ice such as water ice, ammonia ice, methane ice, etc. The presence of these ices makes the mechanisms of material flow and geological changes on this planet very different from those on other planets. For example, magma flows on Pluto may consist of liquid nitrogen or methane, rather than magma similar to that on Earth. Pluto's low-temperature environment also has a great impact on the speed of chemical reactions in equilibrium states. Under low-temperature conditions, chemical reaction rates are slow, and reaction kinetics control the process. Many common chemical reactions are nearly irreversible at Pluto's surface temperatures. Low temperatures alter the chemical stability and reaction direction of substances. For example, under low temperature and high pressure conditions on Pluto's surface, the crystal lattice structure can transform and catalyze specific chemical reactions, such as ice decomposition and gas condensation. These unique chemical processes provide valuable information for studying the material composition and evolutionary processes of the planet. These unique chemical properties and reactions help us gain deeper understanding of Pluto, while also providing important clues for exploring the diversity of planets and planetary systems. The exploration of Pluto opens new perspectives on the diversity of planets in the solar system. This icy planet demonstrates that planets can exist and evolve in different ways. This has significant implications for the search for extraterrestrial life. The low-temperature environment on Pluto could potentially create habitats for ice-based or other chemical life forms, while also helping us better understand the formation and evolution of the solar system and the possibility of extraterrestrial life. Thank you for watching this interesting video.